These are the videos for Concept 7, Graphing Quadratics. The first problem is matching equations to graphs. So one important thing to know here is how to find the vertex. The vertex, if you look at the equation of a parabola, is the point HK. When you look at these equations, we're going to switch the sign for the H, but not switch the sign for the K. So here the vertex is at 1, -2. Here the vertex is at -1, -2. Here it's at 1, 2. And here it's at 1, 2. So looking at the A value, the only equation that has a negative A value is equation C. A negative A value means the graph is opening down. So we can see here that equation C matches graph 1. For the rest, we're just going to match the vertex points. So 1, -2 would be graph 3. -1, -2 is graph 2. And +1, +2 is graph 4. Okay, on number 3, we're going to consider the graphs in number 2. Describe the translation from graph B to graph D. So from this graph to this graph, the direction that it was shifted as well as the number of units. So we can see that graph B had a vertex at -1, -2 versus graph D had a vertex at +1, +2. So in the x direction, we're shifting the graph right by 2 units. And in the y direction, we're shifting the graph up by 4 units. Right, number 4 is to determine the vertex of the parabola. So we have the equation of a parabola where it's easy to find the vertex, and then we have the equation of the parabola here, which is not in vertex form. So we're going to first move the 3 over to this side. So y plus 3 equals x squared plus 8x. In order to get the equation to look like this, we're going to complete the square. So we're going to identify what number can be added to both sides to make this a perfect square trinomial. In order to do that, we're going to take this number divided by 2 and square it. So 8 divided by 2 is 4. 4 squared is 16. We have y plus 19 equals, if we factor x squared plus 8x plus 16, that's a perfect square trinomial, which is x plus 4 times x plus 4, or x plus 4 squared. So in vertex form, this is x plus 4 squared minus 19. So the vertex is at -4, -19. Here's another matching activity, match equation to the phrase that describes its shape. So we have 2 descriptions that match upside down parabolas. B and C are upside down parabolas. So between these, we have a wide upside down parabola or just an upside down parabola. Here, when we look at the A value, the smaller the A value is, the wider the graph. So because we have an A value, but that's between -1 and 1, we have a small A value which makes a wide graph. And then the other one here would just be an upside down parabola, which is not wide. Okay, between the other two, vertically compressed is another way to say that it's wide. Vertically stretched is another way to say that it's narrow. So again, if you have an A value that's between -1 and 1, that is a wider parabola. So that's graph 1. And here we have an A value that's greater than 1, a larger A value, which is a vertically stretched parabola, or narrow.